All right, so we're going to start talking about inverses of relations and functions, okay? These are really not that hard, so just make sure that you're paying attention. If you need the video paused, please just ask your sub to pause the video, okay? When you're graphing inverses, or when you're talking about relations in an inverse, okay, they're pretty much just backwards, all right, is how you can kind of think of them. So, by the way, a relation is something that you don't know if it's a function or not. It's just a relationship between two things. So, for instance, if this is my relation, okay, so let's say that I have x values of 0, 1, 2, 3, 4, 8, whatever, no 3. All right, and corresponding y values of 2, 4, 5, 6, and 7. All right, the inverse, okay, this is the relation that I'm starting with, okay. This is its inverse. If you will notice, the only thing that happened was the x's are now what your y's were, and the x's that you started with are now your y's. They just changed spots, okay? And that's what happens. The x and the y switch spots when you take the inverse of something, okay? So, let's plot those points on this graph right here, okay? So the very first one, okay, your relation was 0, 2. So I'm going to graph this one, this first one, in this pretty purple color. Okay. So I'm going to graph the point 0, 2. So 0, 2. Okay. The next point was 1, 4. So 1, 4. All right. Next point was 2, 5. So 2, 5. Then I had 4, 6. So 4, 6 is going to be about right there. And I actually don't have room on my graph to put the 8, 7, so we're going to leave it off. Okay. The inverse of that, all right, let's graph that in, how about pink? Okay. So if I graph that in pink, that's going to be 2, 0. So 2, 0. 4, 1. So go over to 4, up 1. Okay. Then I've got 5, 2. So 5, 2. And then my very last one will be 6 and 4. So 6, 4. So I'm going to connect these dots, all right, just so we can kind of see one from the other, okay? Don't go past the dots, just connect the dots. All right, and let's connect the other set of dots. All right, now I want you to notice something about them. Notice that they're kind of like a mirror of each other, okay? And that's what inverses are. And this is a really important thing for you to pick up on. Inverses are mirrors, okay? And what I mean by that is they're a mirror across a specific line, okay? So I'm going to put this imaginary line. Remember when we do imaginary lines, okay? They're really not there, but then they are there, okay? Across the line, y equals x. So if you remember from Algebra 1, y equals x actually, okay, will come up through like this. All right. Oh gosh, that's a terrible line. I want to redraw that and make it not purple. Let's just do black. All right, the line y equals x is just this diagonal line, okay, that comes straight through your origin, okay? So it just goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, okay? So if you look at this, if you notice, if this was you standing on this side of the mirror, okay, This would be you on the inside of the mirror, okay? It's mirrored across. Every inverse is a mirror, okay? Now, let's talk a little bit about domain and range, okay? Because I like to talk about domain and range, okay? Domain and range, remember all your x values and all of your y values. So if you recall, all right, from this relation we just graphed, all of your x values come from 0 all the way to 8, correct? All right, all of your y values, that would be your range, go from 2 to 7. So if we were going to put that into interval notation, okay, your domain would be bracket 0, comma, 8. Close your bracket. Remember, brackets mean that number is included. Parentheses mean that it's not included. Okay. Range would be bracket 2, comma, 7. So I went all the way from 2 to 7. Okay. Now, something else, let's talk about the domain and range of your inverse. All right. So the domain of my inverse would be 2 to 7, and my range would be 0 to 8. All right, so if you look at the domain and range of both of them at the same time, if you notice that my domain for my original relation is now the range for my inverse, the range of my original is now the domain of my inverse. So in other words, if the x and y switch, then that means domain and range are also going to switch. So if you can get one, you should be able to get the other one with no problems. Okay? All right. Make sure you've got all that down. Okay, I'm actually going to skip number 2. All right? I don't feel the need to do number 2. So these are going to be off on numbers. Okay? So this is not number 2. I guess this would be number 3. You can number them, all right, however you want to in your notes. Okay. So let's talk about writing inverse functions. So we identify a function using f of x. That's called function notation. Okay. The inverse of a function, all right, we use this as the notation. So this is inverse function notation. This is read f inverse of x. So f inverse of x. So instead of f of x, like this is, that's f of x, instead of saying f of x, we do f inverse of x. That's what this little negative up top means. All right? That little negative means that that is your inverse. Okay? So anytime you find the inverse of something, if you don't put f inverse of x equals, you're going to get it wrong. Okay? So let's take a look at number 3. They give us f of x is equal to 2x. Now, f of x is the same thing as the variable y. So the first thing I'm going to do is replace f of x with a y. All right? Now, I told you that with inverses, x and y switch places. So that's the first thing you're going to do after that. All right? You're going to switch the places of x and y. So now x is going to be in the y spot, and y is going to be in the x spot. So I've got x equals 2 times y. Okay? So guess what we're going to do now? We are going to solve for y. So this is y. I have 2 times y, so I would divide by 2, just isolating the variable here. My 2's are going to cancel. And if we're solving for y, we always want that on the left. Okay, so this would be y equals x over 2. All right, y is by itself, so that means we're done with our problem. But I told you all ago that you never ever find the inverse of something and not put f inverse of x. So you're going to have to say f inverse of x equals x over 2. Okay? That is your answer. All right? So you're just going to replace the y with f inverse of x. All right? Here we go. Let's do another one. All right. Number 4, which I believe is your number 3. Excuse me. All right. Very first thing we're going to do is replace this f of x with a y. So I have y equals x over 3. Okay? Always got to have an x and a y. Always, always, always. All right. Then I am going to switch x and y. So this x is going to go in for the y, and the y is going to move to the x. So this will be x equals y divided by 3. Okay, I have to solve for y. Okay, so y is being divided by 3, so I will multiply by 3. My 3's cancel, so I have y equals 3x. If y is completely alone, then I'm going to say, okay, this represents my inverse. So I've got f inverse of x equals 3x, and I am done. All right? Not that bad, right? Let me guess, you're thinking, are they going to get harder? Oh, they always get more difficult. All right? But that's all right. You will persevere. All right, number 5 here. Or in your case, number 4. Okay? I've got f of x equals x plus 2/3. First thing I always do is I replace this f of x with a y. So I get y equals. All right? Then I'm going to put x plus 2/3. Okay? Now that I have my y and an x, I'm going to switch the places. So x will be the y, and y will move to the x spot. So I've got x equals y plus 2/3. Before you freak out about the fraction, it's really not that bad. I have to solve for the y. I am adding 2/3, so I will subtract 2/3. So that gives me y equals x minus 2/3. Now that y is completely isolated and by itself, I replace it with inverse function notation. F inverse of x equals x minus 2/3. Remember, these are your notes. So if you need to make notations out to the side that say what you're supposed to be doing now, by all means, do that. You can add extra stuff to your notes. Nothing wrong with that. All right. Okay. Number 6. Very first thing I do is replace f of x with a y. Once I have an x and a y, I'm going to flip spots here. So x will be in the y spot, and y will be in the x spot. Okay, this is a little bit different. So my problem is that I'm trying to solve for y, but y is in the denominator. So the very first thing I have to do is get it out of the denominator. So if I am dividing 5 by this whole y plus 1, then I'm going to multiply by the whole y plus 1. Please put it in parentheses. You're going to keep it as a group. So multiply by y plus 1. That means it's going to cancel over here, and that leaves me with y plus 1 times x equals 5. Now, most of you are going to want to distribute the x, but if you distribute, then you're going to have 2 x's in your problem, okay? And that's going to be disastrous. So this is x times this, right? So to get rid of the x, I'm going to divide by it. So I have 5 divided by x. My x's cancel. So I have y plus 1 equals 5 over x. And then the very last thing I have to do is get rid of this 1. I'm adding 1, so I would need to subtract 1. So I get y equals 5 over x minus 1. Now that y is completely isolated, I will replace it with inverse function notation. F inverse of x equals 5 over x minus 1. And I'm done. Okay, that one was a little bit more difficult, but still not just terrible. Okay. Okay, moving on. Number 7, or in your case, number 6. All right, very first thing you do, replace f of x with a y. Okay, once you get a y and an x, you switch spots. So x is now in the y spot, and y is now in the x spot. All right, once I have them switched, I have to solve for y. So here's the thing. Y is being divided by 4, and then out to the side we subtract 5. Remember, if you do reverse order of operations, the subtraction part has to be undone before the division part is undone because they're separate things. So first thing I do is I add the 5. So I get x plus 5 equals y divided by 4. All right, now I have y being divided by 4, so to get rid of the 4 I will multiply by 4. Now I am multiplying both of these numbers on this side by 4. Not just the first one, not just the second one, everything. Okay? It's both sides times 4. So that means I'm going to actually have to do a little more work here. So my y is by itself. So I have y equals, I have to distribute. 4 times x is 4x. 4 times 5 is 20. Now I am fully simplified. Y is by itself, so I will replace it with inverse function notation. F inverse of x equals 4x plus 20. All right. Honestly, the only thing new to you in this lesson should be switching the x and the y. Okay? Everything else is just Algebra 1 material for solving for a variable. All right? So let's do a couple that are kind of like number 5 for you. All right, we're going to throw in a g of x. Remember, g of x, same thing as f of x, just a different letter. It still represents a function.
Features at this time were released for PCD students. Make sure that you're on the list to go. Double check. It's your responsibility. PCD may leave at this time.
Okay. So I want you to notice something. Notice that there is a minus out front here. Listen to me carefully. When there is a minus in the front, you're going to put it with whatever is on the top. Okay? You don't put it with the top and the bottom. You don't put it with the bottom because that's just improper half the time. So put it with whatever is on the top. So go ahead and replace this g of x with a y. And then rewrite this with a negative 4. Okay. So we're going to go ahead and put that negative on top. And keep everything else the same. All right. So after we've replaced and we have a y and an x and we have moved a negative, if there's a negative here, move it on top, we're going to switch the x and the y. So x was now in the y spot and y will now be in the x spot. Okay? All right. So now your job is to solve for y. So y is involved in the denominator of this fraction right here. Okay? But we have this little number out to the side that needs to move first. So we're going to add that to the other side. So now we have x plus 1 equals negative 4 over y minus 3. All right. And now this is kind of like the one we did a while ago where y was in the denominator of this fraction. And you have to get it out. So remember, we're going to group this as one thing so that we can multiply by it on the side. So I'm going to multiply by y minus 3. Now remember, that's times all of this right here. So you also need to group that. Okay? These two will cancel. So now I have y minus 3 times the x plus 1 equals negative 4. Now, pay attention to me here. This is what I'm solving for. Everything else over here needs to go away at some point. So since all of this is being multiplied by the x plus 1, I'm going to divide by the x plus 1. Both sides. So now these cancel. Now all I have left is y minus 3 equals negative 4 over x plus 1. All right, my last step in isolating the y is to add this 3 right here. So I add that, add it to this side. These cancel. I have y equals negative 4 over x plus 1 plus 3. Remember, after you get y by itself, you replace it with inverse function notation. F inverse of x equals negative 4 over x plus 1 plus 3. And I guess actually, technically, all right, we started with a g, so let's do g instead of f, just so we can remain uniform. Okay. So that one was a little more difficult. It kind of combines several things that we've talked about all in one problem. All right. So just because I'm a nice person, we're going to do another one like that. Okay. Just so you have a little bit more practice with some that are a little bit more difficult. All right, number 9, or in your case, number 8. It's set up exactly the same way. Notice that we're doing G again, so we'll make sure that we keep the G. All right, so if we notice, there is a negative out front, so we're going to make sure that we pull that up with the 3. If 3 were negative on top, it would make a double negative, which would make it positive, just so you know there. So we're going to replace the g of x with a y. This negative is going to move up with the 3. Everything else remains the same. Okay. Now I'm going to switch x and y, because again, I am finding the inverse. All right. Now I'm ready to solve for y again. So if you notice, y is in the denominator of this fraction, but we do have something on the outside. Let's move it over first. So I'm going to add 1. So I get x plus 1 equals negative 3 over y minus 3. Now all that we have left is the fraction that the y is involved in. I'm going to get this off the bottom by grouping it and multiplying it, both sides. Now please remember, it's this times all of this, so you actually need to group both of those. If you don't group both of them, it's going to be incorrect. So these will cancel, and now I have y minus 3 times x plus 1 equals negative 3. Still solving for this y. So since this whole parenthesis is being multiplied by this one, I'm going to go ahead and divide by the x plus 1. That leaves me with y minus 3 equals negative 3 over x plus 1. And then my very last step is that I just have to move this negative 3 over. So I'll add 3. So I have y equals negative 3 all over x plus 1 plus 3. Now, you're not finished, because once you have isolated the y, you're going to have to change it to inverse function notation. Oops, I did it again. We started with a g, right? So g inverse of x equals negative 3 over x plus 1 plus 3. All right. So a couple of more difficult ones there for you. All right, and then I have a couple more that I'm going to show you. All right. Number 10. Okay. So I'm going to go ahead and replace g of x with a y. Then I have to switch x and y. And honestly, you could combine those two steps into one once you got the hang of everything. All right, so now I'm just simply solving for y. Okay, so I will save this part right here for last and move this away first. So I've got to add the 4. So I have x plus 4 equals negative 1/3 y. Alright? When you multiply by a fraction, the way you get rid of that is to divide by a fraction. But dividing by a fraction is the same thing as multiplying by its reciprocal. So remember, the reciprocal is that you just multiply by this number, but flipped. So we'd multiply by negative 3 over 1. Everything gets multiplied by negative 3 over 1, which, by the way, is just negative 3, right? So over here, this cancels. So I have y equals, and then I have to distribute. Negative 3 times x is negative 3x, and negative 3 times 4 is negative 12. Once y is isolated, we replace it with inverse function notation. And I did it again, didn't I? Alright. We started with a G, so we'll make it a G. Okay. And there's your answer. And I got one more for you. I don't know why this graph is on here. I don't want to graph it. Okay? I don't think I want to graph it. Okay? Here we go. So I'm going to do this out to the side. Alright? And I don't like the ends, so let's just replace the n with an x. Okay? So that would make this y equals 3x plus 9. So if I switch the x and the y, I get x equals 3y plus 9. And then I'm going to solve for y. So I subtract 9. I get x minus 9 equals y. I divide by 3, both sides. Oh, I forgot my 3 right there, didn't I? Divide by 3 both sides. I get y equals x minus 9 divided by 3. And my last step is to replace that with g inverse of x. I finally remembered, didn't I? Equals x minus 9 over 3. Okay? And there that is. I'm going to save the inverse stuff for graphing for later. Okay. All right. I think that's about it.